He has to control his arm.
Somebody go up there and trace two angles on the picture for me with, I don't care if you use my pen or just one of the other pens, and
Trace two angles?
because we need a pair, right? So trace two angles, then tell us what kind of angles they are. No, on the actual picture. No, on the actual picture. Stop. Did you trace one? I can't see. So that's one angle. Alright, so you got two angles there, right?
Yeah.
What are they to each other?
You got right angle and a acute angle.
What are the two angles to each other though? Hint, it's on the board.
Example.
Complementary.
How do you know they're complementary? They add up to 90 degrees. Now, we're not supposed to assume that those are 90-degree angles, but I'm going to allow you for this little exercise here.
They're also adjacent.
They're also adjacent angles, so if you could have said that and that, we wouldn't have to assume anything, right? Somebody go up and trace two other angles.
Yep.
Alright. Do me a favor, Harry, and do it somewhere away from Dawson's. You don't have to erase it. Just so that you can trace the same angles, just that way we can see it a little easier without the black being in the way. What kind of angles are those two angles to each other?
Supplementary.
Supplementary. What's it mean to be supplementary?
Adds up to 180.
Adds up to 180. So you trace these two angles, they add up to 180. If those two angles are supplementary to each other, I said we couldn't assume that we had right angles, but if they are supplementary to each other, and they're like they are right there, what's the only kind of angles that both of them could be? They have to be 90-degree angles, right? So, if I get 8 different pairs,
Can't you draw a triangle?
that'd be 3 angles.
Can't you draw a triangle?
That'd be 3 angles.
Would vertical angles be acceptable?
I didn't know if you heard me.
Show me. Now you drew 4 angles.
Well, you can ignore these two. Ignore.
Alright. So vertical angles, what do we know about vertical angles?
They're both congruent.
They're congruent, they're exactly the same. So he drew those 2 angles, one up this way, one down this way, they're vertical angles. Could he have just easily picked out the 2 that he marked out as vertical angles? We already talked about a second ago, Dawson drew those 2 that we said were complementary, and somebody mentioned those 2 angles are also what kind of angles to each other?
Adjacent.
Adjacent, they're hooked to each other. You got pictures like this one. If I told you by the end of the year, and we're going to do a lot of stuff like this, if I told you this angle right here was 72 degrees, how many other angles in that picture could you find?
Like,
18.
a lot of them. Well,
Give me
all the ones on
there.
the-
That's the answer I wanted. I give you that one angle, we could find every other angle in that picture. Okay, by using all that stuff that we talked about. Plus, you'd have to use a couple things that we haven't talked about yet, which would deal with the triangles. Which one of the things you probably know for sure already. 3 angles of a triangle add up to be how much? 180. All right, that's something that you probably learned in some other math class, I'm guessing.
Yeah, I learned that in math one.
Math 1. Is that first grade? Is that what it is? Open up your books to page 52. Page 52. Few things just to make sure that everybody understands. If you haven't been going on Moodle
lately.
If you haven't been going on Moodle there's videos of what we do in here each day, the video lessons. So if you happen to miss a day, because I know there's a few field trips coming up here in the next week or so. If you miss a day for a field trip, that's not an excused absence. All right, a field trip is a field trip. So if you miss a day, it's your responsibility to keep yourself caught up. Does that make sense? So if I give an assignment page 258 that day and you're out because of the field trip, number one, you should have came to me before if you knew you were going on the field trip and got the stuff. Number two, come back to me since we're on block scheduling, come back to me the next day to get the stuff before you have me in class, because when you come in here that next day and you don't have, well, and you say, I wasn't here because of the field trip, I'm going to say it's a 0, because that's the way it's supposed to work, all right? So come in here, get it early before it's due that day. Especially this week, be trouble because see, there's a couple of days where the field trip is. Well, Wednesday and Thursday in this class we have a test over chapter 1. So if you're going to miss the test, you got to come in and get it made up before you come back to class that next time. That's your responsibility, all right? And you don't want to take a 0 on a test. That would really not work out well. Friday. That'd be Friday. Yeah, Friday. So just get with me like an intervention. I can give you the assignment on Friday, or it's on Moodle right now. So do what now? Your test will be Wednesday. Does that make sense?
Gotcha.
So, a couple other things. We will have a test. When we have a test in here, just because this will be our first chapter test. When we have a test in here, the way it'll go, we'll come in and I will review. Sometimes I will allow you to use your binder. Sometimes I won't. Most of the time I won't. Sometimes I might say, like today, I think today I'm going to allow you for this test to use one sheet of paper. So as we're going through the review, if you want to write down the review and copy some things in it and use that sheet of paper for your notes or for the test, that might be a good idea. Does that make sense?
Write everything down on one piece of paper.
Now, don't forget though also that these review notes that we do today are part of your binder. When I collect your binder at the end of the 9 weeks, that has to be in there. So that gets counted then also. So don't use it on the test and then forget to put it back. Do what now?
So it's like everything I do, I just have to put it back.
Notes. We have.
That's good.
We have 3 parts of our binder. You have your notes, postulates and theorems, tests, and quizzes. So those are the 3 parts that have to be in your binder when you turn it in. All right, notes, postulates and theorems, tests, and quizzes. Does that make sense? Are you lost, Jaden? lost because she. Which question, Dalton?
No, I had
Binders
to-
aren't due when you have this stuff. so-
No, binders are due at the end of the 9 weeks. Binders, you'll turn in binders for the test.
Basically almost everything. Except home.
Right, homework and some of the packets and stuff like that. The other thing, the other paper that you grabbed up there for the online stuff, I finally got that figured out. If you go to, and I could probably do it right here real quick. I think I still got it pulled up. Maybe not.
This is a scrap piece of paper.
If you go to Big Ideas Math, I can get it to come up. Not sure why mine's doing that, but you go to Big Ideas Math. I actually, have it on my favorites here somewhere. Can't see it. There it is. And I'm already logged in, but underneath log, where it says to log in, if you're new, so you go there because you haven't logged into it yet. If you go there, you're going to put in that access code that I believe is right on that paper, right? Put in that access code. I don't think the capitals make any difference, but you put in that access code and then you hit next, and then it'll ask you to set up your own sort of account. And it'll stick you right into the geometry because it knows what that goes along with. And you can get on there and it's got like practice tests, practice quizzes.
Okay.
It's got a copy of the book on there, stuff like that. Again, I'm not sure what all it has on there for you guys because I can't log in as a student. As soon as it sees my name, it throws me in as a teacher. And then I see all the stuff that I see. So I'm not sure what exactly you guys see. Same with Moodle.
You can view as a student though.
But I can't view from the beginning as a student. So I can see what you see on my Moodle page as a student, but I can't see how you get to that point. If that makes sense. I mean, yeah, Alyssa, I could look up your password and go in and act like I'm you, but I've never done that before. So I guess I could do that. I just never have.
That'd be creepy.
That's probably part of the reason I've never done it. Page 52. We're going to go over several of these problems just to try to run through them real quick to make sure you understand them. So just help me out. As long as Ivy keeps herself completely awake. Can you handle that, Ivy? She keeps herself.
I'm just agreeing with that.
Maybe I should just collect this and go on. Yeah, I thought that was going to be nice.
No, please don't.
So, why you go? That makes no sense. Adjacent complementary angles. We want two angles. Make sure you're watching carefully. Again, all you got to do really is follow along. If you want to write down stuff, if it helps you, you do whatever. But follow along in your book. Adjacent complementary angles. And help me by answering questions. If you just sat here and nobody just answered me, Harry's the only one that's talking and answering, then we'll stop and we'll go on, and we could take the test today. I have it up there. It's easier that way probably. What's adjacent mean? Neighbors. Complementary means adds up to 90. So we want two angles that are hooked together in this picture, in one of those two parts of the picture that are hooked together and add up to 90. Well, if they're angles, we know that we got to use the angle symbol to name them. So I'm looking at all those pictures and everything.
L and would equal 90.
What does?
L N and what? L J N.
So That's the whole angle. We need two angles.
56 degrees and 30
Name one of those for me.
Angle LJM.
LJ, say the last letter again.
M.
Now, what's the other one?
MJN.
MJN. Everybody agree with that? So that's this angle. My picture's gonna be messed all up by the time we get done. And that angle. Those two angles add up to be 90? Are they hooked to each other, adjacent to each other? Yeah. Adjacent supplementary angles. This one's a little tougher. People can't picture this one because you gotta be able to use your imagination. We want two angles. What's supplementary mean again? Add up to 180. And they gotta be neighbors, gotta be hooked together. LJ, say it again. LJN. That's this angle. LJN. Does everybody see that angle?
Yeah.
Now, why do most people get mixed up on that angle?
There's a line going through.
There's another ray going through it, making two other angles, right? But we're not looking at that. We're looking at just this angle, sort of. You got to imagine that ray JM isn't in there anymore. And what's it supplementary to?
LJK.
LJK. Angle LJK. Make sure when you're naming angles, you're naming them with 3 letters, symbol out front. How about, let's skip number 5, let's go to number 6. Non-adjacent supplementary angles. What do you think non-adjacent means?
So I'm guessing MJP and LJK.
What's non-adjacent mean?
Not beside each other.
Not beside each other, not hooked to each other. And we want them to be supplementary. So they still got to add up to be how much? 180. So the first thing we probably need to do is look at some of these angles and find a couple that add up to 180. Anybody see a couple of numbers that add up to 180?
Well, I guess 90.
KJP and MJP.
Say it again.
KJP and MJP.
KJP. We don't have that number though, do we? We could find it. There's an easier pair.
FJH and LJM.
Say it one more time.
FJ,
F what?
FJ, FG.
Oh, okay. I didn't know.
So FGH is up here, right? How much is it? 124. We want another angle that's not hooked to it that adds up to 180 with it. What's the other one?
LJ.
LJN. That's this one. That one. Do those add up to 180? Yeah. Remember, when we talked about this, supplementary angles, if you have a linear pair, then we know a linear pair like we had the first time here, together they made a line. And they had to add up to 180. These two still add up to 180, so they're supplementary, but they're not a linear pair. Alright? So linear pairs are always supplementary, but supplementary angles aren't always linear pairs. Spell it out for me. Just rip it out. Number 7, what's number 7 say?
Angle 1 is complements of angle 2 and angle 1 equals 23. Find angle 2.
Angle 1 is complementary to angle 2. Fill it out on the side. If they're complementary, what do we know about them?
They're beside each other. No, they're beside.
They add up to 90. So how could we find angle 2? Subtract 90 minus 23. Somebody help me out. What's 67? 77? Which one is it?
67.
67? What's that number 8 say?
Angle 2 is complement of angle 4.
Angle 3 is complementary to angle 4?
Yeah.
Same kind of problem, right? So let's skip down. What's number 9 say?
Supplement.
Alright, so angle what?
Angle 5 and 6.
Angle 5 supplementary to angle 6.
78 degrees.
Which one's 78 degrees?
Angle 5.
Angle 5 equals 78. How you gonna find angle 6 in the measure of angle 6?
180 minus 78.
180 minus 78, what do you get? 102 degrees. Those are pretty easy. If they give you one, you just have to know, are they adding them up to 90 or are they adding them up to 180? If they're complementary or supplementary. 10 probably says supplementary again, right?
Yeah.
11, apparently this is the picture in 11. We're going to find the angles. I don't know what the question asked. It doesn't really matter.
They don't.
What, what do we know about these two angles?
Now we got to solve them.
They got to add up to 180, right? So they're supplementary. What equation can I set up?
3x plus 5
Make sure you're watching this.
plus
Equals 180. So we're going to set that up for that picture. Is it always going to be that way that we set up all these? No, it depends on the problem. I'm going to solve this real quick. 13x, Sandra says, and a 5 and a -7 give you what?
-2.
-2. Make sure you don't get in a hurry there. A lot of people make a little mistake right there. Add 2 to both sides. You get 182 over there. Equals 13x. Going to divide by 13. Somebody help me out with their calculator. What's it?
13.84.
That don't sound right.
13.8. I got the answer right here.
That don't sound right. What?
Is it?
14?
Oh, yeah.
Come on,
I'm gonna put
man.
180.
So we got 14. Once we know 14, we're just going to take it over here, plug it back in. I'm going to plug it into this one because it's easier. 10 times 14 is 140. 140 minus 7 is 133. So that angle right there would be 133 degrees. That's one of our answers. These two got to add up to 180. So if that's 133, we subtract that from 180. 47, is that right? What equation would we set up on number 12? What's different? They're complementary, right? So 15x minus 2 plus 7x plus 4 would equal,
22x.
that's 90, right? Equals 90. Make sure you guys want, a lot of you want to start collecting like terms and stuff before you have an equation. You got to have an equal sign. You got to have that equal sign before you start doing all that. Otherwise, you get confused. 22x, a -2 and a +4 gives us +2. That's 90 minus 2. It looks like 88 over there equals 22x. I'm guessing x is going to equal 4 there, right?
Yeah.
Once you know x is 4, take it back over here. 7 times 4 is 28. 28 plus 4 is 32, so that angle is 32 degrees. These two got to add up to 90, so this angle here has to be 58 degrees. I would highly not these. These are basically the same thing. Let's just set up the equation on these two. I was thinking this is a different kind of problem. They just don't give us the picture. If it helps you to draw a picture, then draw it. But we're still going to set up an equation. What am I going to do with those two expressions? Add them together and they equal how much? 90. So tell me the equation. Equals 90. Notice, what did I not put in here when I put that stuff in? The parentheses and the degrees, right? You don't need that in this case. If there had been a 5 or something out in front of that, then we need the parentheses. But otherwise, you could just drop off those parentheses. Solve that just like we solved the other ones. How about this one? Let's set it up.
3x minus 17 plus half x minus 5
Equals,
equals 180.
make sure, because at least set up the equation. Even if you hate fractions and can't do anything with fractions, because I know there's a lot of those students, as soon as they see a fraction, they give up. At least set up the equation on the test. You get a point. It's better than a 0. All right? Set it up. If it's a fraction that's a half, change it to 0.5 and use your calculator. If it's a fraction like 1/3, it doesn't work out so well. You got to know how to deal with fractions, or how to use your calculator and let your calculator do the fractions. Okay? You'll never ever, I won't ever change anything to 0.5, but if it helps you to change it to 0.5, then do it. I'll always leave it as a fraction to do it. Do you guys want to see me work this one out or not? Nah? Yes? So if I got 3x and 1/2 x, I'm going to rewrite it up here so I don't have to bend down. That's 3.5x. Negative 17 and negative 5 is negative 22, just collecting like terms, equals 180 still. Add 22 to both sides. And your calculator will do most all of this. Once you get to the fractional part, that's 202, is that right? Forget that the half's there. If that just said 3x, what would you do next? Divide by 3. If the half is there, guess what you still do? You still divide. So you take 202 divided by 3.5, and on your calculator, most all of them's got the ABC button on them. You just put in 202 divided by 3 ABC button 1 ABC button 2 equals.
57.7.
That don't sound right.
I did 3.5. That's why. I got the ABC. Which is that lazy.
Did I do something wrong? What? Do what? $202. I didn't do something wrong, did I? Negative 5. Divided by. I thought it came out even. That plus that's 3.5. Negative 22, you add 22 to both sides, so you're supplementary.
Oh, I know what you did.
What did I do wrong?
It's supposed to be plus 17 on there.
Oh, my whole problem was wrong, wasn't it? Yep. Oh, that would change things. So that's supposed to be a plus there. Positive 17 and negative 5. That would give us, that's going to change this. That's going to make that a positive 12. Then we're going to subtract 12 on both sides. Get rid of all this. Here, I thought Dawson was wrong and I had it messed up. So we're going to subtract 12. 180 minus 12 is 168. Now let's try it. What's 168 divided by 3.5?
48.
So x equals 48. Now, again, did they ask us to find x?
No.
To plug it back in. When you go back up in here to plug it in, don't let that confuse you. You're just saying half of whatever x is. What's half of 48?
24.
24 minus 5? 19. So one of the angles is 19. How can we find the other one?
180 minus 18.
180 minus 19, which is what, 161? So those are our two answers for that. Don't let that confuse you. Yeah, I think I remember that from last year. I never went back and fixed it. Name me a linear pair in that picture, just real quick. Two angles that are linear pair. Any two. Forget that it says 1.
1 and 4.
1 and 5. That's one that even answers their question, right? Remember, 1 and 5, a linear pair has to form what together? A line. Does everybody see that line that 1 and 5 form together? Name a linear pair with angle 7. Angle 6, right? So 6 and 7. Give me something different. 8 would work. Linear pair. Not only are 7 and 8 a linear pair, but we also know that what other name are they? They're adjacent and supplementary.
Oh, they just got all the things.
Yeah. 7 and 8 are special, aren't they? They get everything. Are 6 and 8 vertical angles? Yeah. So what do we know about 6 and 8? If I told you angle 6 was 50 degrees, what could you tell me about angle 8? It's 50 degrees.
You got bless you.
2 and 5 are 2 and 5 vertical angles. No. Here's something that might be helpful.
What did it be, 2 and 3?
Yeah. When you're looking at vertical angles, watch this. Vertical angles, if I look at angle 5, vertical angles have to be angles whose rays are opposite rays to each other. So one ray in one angle, one ray in the other angle are opposite rays, then the other pair of rays are opposite rays. So if I look at those are my 2 rays in angle 5.
It would be 1 and 3.
If I made the opposite ray for this ray, it'd go down here, right? If I made the opposite ray for this ray, it'd go up here. So you see that blue angle? That's the one that's vertical to angle 5. So again, have to use your imagination, sort of get rid of that. Erase the other ray. These are the ones. It might be very, very helpful to you to write down these next 3 or 4. Because I guarantee we're going to do a whole bunch of these. You might want to write this down, like write one of them down so that you understand this. Because we're going to do a whole bunch of problems like this throughout the year. And the way I do it is the way I think is the easiest way. So once you learn how to do it that way, all the rest of them should be easy. These are pretty easy ones, and we'll get to a lot harder ones later on in the year as we go. Anytime you see a word problem, and it says something like 2 angles, anywhere in there it says 2 angles, I want you to start off that problem by doing this. Angle 1, angle 2. Ignore that string mark there. Let me erase it. So every time you do one of these 2 angle problems, you write down angle 1, angle 2. Then it's going to describe it to you somehow. Don't do that. It's going to describe it to you somehow, and we're going to use that to tell what angle 1 and angle 2 are. The measure of one angle is twice the measure of the other angle. So if I have angle 1 here and I don't know what angle 1 is, last year in algebra you learned anytime you don't know something, what do you put in? X. So I'm going to make angle 1 X. Sometimes it'll be X, sometimes it might be something different, depends on how they describe it to you. They said the measure of one of the angles is twice the other one. Well, if this one's X, angle 2 then has to be twice that, so what's it going to be? 2X. And I know these are easy, and some of you are sitting here going, why would I do all this for this problem? It's just easy. And you're right. As we get to harder stuff later on in the year, if you do this process, it's going to make those harder problems easier. We know that these 2 angles are a linear pair. If they're a linear pair, then what do we know about them? They add up to 180. So what equation can I set up? X plus 2x, the first angle plus the second angle, just like in the other problems. And that should equal what? 180. And then you solve it just like we've been solving all the others. What's x come out to be? 60? Is that our answer? They said find the two angles, right? So what's the measure of angle 1 here? 60 degrees, that's one of our answers. Measure of angle 1 equals 60 degrees. What's the other one? 120 degrees. That's the measure of angle 2, so 60 and 120. Second one, two angles form a linear pair. The measure of one angle is half the measure of the other. Same idea. You're going to do this. Angle 1, angle 2. What are we going to let angle 1 be?
X.
X again. This time they explain the other one to us. What do they say about the other one?
That's 9.
It's half of it, right? So what do I put down here?
1/2.
1/2 x. What's our equation going to be?
X.
Plus
1/2.
1/2 x, and you guys, if you like, you can change that 1/2 to what? 0.5. And they told us they were a linear pair, so what's that tell us about? They equal 180. What's x plus 0.5x? 1.5x equals 180. Somebody help me out, divide 180 by 1.5. What's x equal? 120?
Yep.
So x equals 120. So what's the measure of angle 1?
X equals
120, right? What's half of 120 if we plug in there?
60.
So those are the two angles. Next one, I'm going to start off the next one same way. Measure of an angle is 9 times the measure of its complement. We need to know that here in a minute. Dealing with two angles again, so I got angle 1, angle 2. Every time you see one of these problems, you start off by doing angle 1, angle 2. Do we know angle 1? So we make it x. The other one is what in relationship to that first one? 9 times it. So how am I going to write that?
X plus, oh, that one, 9x.
9x.
But you're talking about the equation.
What's complement mean?
Equals 90.
So these two should add up to 90. Now the equation.
X plus 9x equals 90.
X plus 9x equals 90. Add those together, you get 10x equals 90. Divide by 10. What's x equal? 9. Once we know that x is 9, what's the measure of angle 1 here? 9 degrees. How about angle 2? 81 degrees. Measure of an angle is 1/4 the measure of its complement. Same idea. I'm going to set this one up, then we're not going to solve it, but you guys can tell me the answers if you want. You got angle 1, you got angle 2. We're going to let angle 1 be x. What's angle 2 going to be then? 1, my pen won't write down that far. 1/4 x. The equation would be x plus 1/4 x equals 90. Anybody just figure it out by using their head? What'd you get when you just figured it out by using your head? 72 and 18. Now let's make sure. So we said one of them's 1/4 the other one. So that means if we times this 18 by 4, what should we get? The other one, right? What's 18 times 4? Is that 72? Yeah. So if you can figure them out in your head, sometimes I'm not going to throw a fit about that, but I am going to tell you, if you figured all these out in your head and we get to the harder problems and you can't do them because you don't know how to set them up this way, that's going to hurt you. So even when you were doing problems last year in algebra and it looked like this, and Mrs. Brown or Mr. Harrison or whoever said, work them out. And you said, I don't have to work that out, x equals 2. Well, they knew that you could figure them out in your head. They didn't want you to figure them out in your head. You got to know the process so that you could do the harder problems when you got to something like that, and then you actually had to do a process to get the answer. You couldn't just figure it out in your head. These are those two error problems. It says angle 2 and angle 4 are adjacent angles. Is that true? No. The way we could fix it, get rid of angle 4. Angle 2 and what angles are adjacent angles? Angle 3, you could also put angle 1 in there. Angle 1 and angle 3 form a linear pair. Is that true? No. We could get rid of the 3 here. Angle 1 and what angle form a linear pair? 2. If angle 1 here, this is that picture out of the book, isn't it? If angle 1 here is 58 degrees, we want to find the angle supplementary to it, which happens to be that angle right there, where they got the wires going down through there. How would you find that angle? 180 minus 58, what's that give you? 122, is that right? And then they said an angle supplementary to angle 2. If we look out here, if they extended that on out, angle 2 and that angle right there would be supplementary. If you're building stuff like this, probably be a good thing to know. If this angle is one thing, what's this angle over here have to be, right? So that you make sure you're building this bridge and it doesn't go like that down through there. You want to keep it so that together they form 180 degrees. They told us angle 2 was 24 degrees. Well, if angle 2 is 24 degrees, what's the other one? 156. What 28 say? Probably gave you this one just because I like baseball so much. So what do we know about this angle right here? 90 degrees. That's 90 degrees, even though it doesn't look like it in the picture because pictures sort of distort things when you're looking at them sometimes, right? They want to know if I hit this ball and made a 27-degree angle with third base, the third base line, what angle did it make with the first base line?
Would be 90 versus 60.
What do we know about those two angles? They're complementary. So what would that be like? 63 degrees. If angle U is 2x, angle B is 4 times angle U. Which one would make those two, which x would make those two complements? Could you just stick them in there and figure it out? And please, on like the end of course test, if they give you a problem like this, don't go, man, I don't know how to do nothing like that. Start sticking them in there and seeing how it works out. That way you at least get some good idea. B? Are we going with what Jacob says? Sure.
Yep.
He's just a genius. All right, these are the little harder ones. So these are a little harder than the first ones. The measure of an angle is 6 less than the measure of its complement. Same thing, you're dealing with two angles. Angle 1, angle 2. You know, Dawson's paying close attention to this because these are the hard ones, Dawson.
Mm-hmm. I wrote down the first one. Like you said write down the first one. At least one.
The measure of an angle is 6 less than the measure of its complement. What are we going to let angle 1 be? X. Now, here's where you got to be careful. We know complement. We know that tells us 90. We'll get to that in a minute. It says the one angle is 6 less than the other. So if one of the angles is x, how are we going to write 6 less than that? X minus 6. Notice, got to know this. Anytime you see less than, if we're translating this, it goes 6, less than tells us minus the measure of the other angle, which we said was x. But if it says less than, Is it gonna be in that order?
No.
If it's less than, they got to be switched around. Right? You have to switch them around. Anytime you see less than, it tells you to subtract and switch the order. So if I say 4 less than 7, what's that tell me to write down? 7 minus 4. And what number is 4 less than 7? 3. 7 minus 4 is 3. If we did it the other way, we would get -3, and that's not correct. So anytime you see less than, you've got to switch the order that the two things go in. If I set up an equation from this, what's my equation going to be? X plus x minus 6 equals 90. If I solve that real quick, I'm going to solve it just real quick. Divide that by 2, it looks like x equals 48. What's the measure of angle 1 then? 48. What's the measure of angle 2? 42. 48 minus 6 is just 42 degrees. Next one. The measure of an angle is 12 more, so on, so on, so on. It's the same thing. I'm going to start off this way. Angle 1, angle 2. What are we going to let angle 1 be? X. 12 more than twice the measure of its complement. So how am I going to write that? 12 more than means plus twice the other angle, which is 2x if my pen would write. Again, it's got than in it, so what's that actually telling you to do these two things? Switch them around. So it should actually be 2x plus 12. But with addition, does it matter if you turn them around? No. 5 more than 3 is the same as 3 more than 5. Right? With addition, it makes no difference. If you add those up, you could collect your like terms. It said complement, so it's 90. It's 3x there plus 12 equals 90. If I solve this in my head, it looks like that's, what is that, 78. 78 divided by 3 is 26. So x equals 26. Plug it back in. This angle's 26 degrees. 2 times 26 is 52. 52 plus 12 is 64 degrees. What should those two add up to be? To make sure I didn't make some mistake. Do they add up to 90?
Yeah.
So again, make sure you're doing that. Same idea on this next one. I'm not going to do the next one. I'm going to do the last one here real quick. First angle, x. Second angle. Second angle. 15 less than 2/3 the other one. So what's that tell you? 2/3 x minus 15. Remember to switch them around. We're going to add those up. I'm going to do it up here. So we got x plus 2/3 x minus 15 equals, they're linear pairs, so 180. Start right at 90. We collect like terms. X and 2/3 x gives us 1 and 2/3 x. We'll add the 15 to the other side, so that's 195. Next thing you're going to do is divide by 1 and 2/3. Again, don't change 2/3 into a decimal. What's 2/3 as a decimal? 0.6 repeating. That's not a nice number, is it? Because once you change it to that 0.6 repeating, unless you leave it in your calculator for the whole problem, it's not going to work out all nice and even like it should. Now, if you change it to in your calculator, I take Dawson's calculator here and I do this. I know that 2/3 is 0.6 repeating, so I take 195 divided by 1 point, and I do this 6, and just keep repeating a whole bunch of 6s out like that. Just punch in a whole bunch and hit equals. The calculator understands exactly, right? The calculator understood what I was doing there when I repeated all those 6s. But if you just put in like 0.67, because it rounds off to that, is it going to understand that?
No.
No. So I came out with x equals 117. Could we have took his calculator and did 195 divided by 1? No, that's what we just did. I'm going to use the ABC button this time. ABC button 2, and the ABC button again, 3, and hit equals. Yeah, your calculator's different.
Special.
No, I got to hit the, I didn't hit the save.
Yeah, you gotta hit your special for math.
So you could use on the Lular calculators, the TI-30s, you just hit ABC button and hit ABC button again to do a mixed fraction. His, you gotta do something special to do so. Real quickly, we'll run through these. Complement angles are adjacent. Always, sometimes, or never. Sometimes. Complementary means that they have to add up to what? 90. Doesn't mean that they have to be hooked together. Angles in a linear pair are supplementary to each other. If you have a linear pair, are those angles supplementary? Always, sometimes, or never? Always. Vertical angles are adjacent. Never. Yeah, I told you earlier, my typing's not very good, so you're lucky it's up there at all. If an angle is acute, then its complement is greater than its supplement. Never. All right? If you have an acute angle, first of all, if you got complementary angles, both of them have to be what? Acute, right? They can't be obtuse angles. If an angle is acute, that's one I just did. If two complementary angles are congruent, then the measure of each is 45 degrees.
Yeah.
Complementary means what?
Yeah.
Add up to 90. If you got two angles and they add up to 90 and they're congruent to each other, both of them have to be how much? 45. What if, so that's always. What if I change this? It said two angles are supplementary and congruent. What would that number out there have to be? 90. If two angles are both supplementary and congruent, then the only way that they can be that way is if they're both 90 degrees. This is what I was talking about a second ago. If I have two angles and they're complementary, both of them have to be acute angles. There's no other way around it. You can't have an obtuse angle and some other angle and them add up to 90, right? But if I have two angles and they're supplementary and one of them's acute, then the other one has to be what?
Okay.
Obtuse. Because that's the only way it'll work out to add up to 180. Explain why an obtuse angle does not have a complement. We just talked about that.
It's too big.
It's too big. It's already got more than 90, right? So can't be.
Can you have a right angle and a obtuse?
That
It would be like, it would be.
be too much, right? If they were supplementary. If it's a right angle, what's the supplement of that?
90.
Another right angle, right? So that's the only way that would work out. Please don't forget, even though I did it here, what symbols do you think should be above CA and AF there? Rays? It's got to be segments. How do I know it's not rays or lines? Segments can be congruent. Can rays be congruent to each other? No, because you can't measure them. Congruent means same measure. Let's run through all these. Segment CA is congruent to segment AF. True or false? How do you know that that's true? It's got the tick marks on it, right? Does everybody see those two tick marks? It's got the tick marks on it. Points CA and F are collinear. True or false? True. Or they? What's collinear mean? Same line. Angle CAD. Angle CAD, that's this angle. If I see that angle, is congruent to angle EAF. It's that angle. True or false? Are they vertical? They're not vertical, are they? What angle is vertical to EAF? BAC, that one there. These two would be congruent. Those two, no. So that's false. Segment BA congruent to segment AE. True or false? We don't know, do it, so it's false. Did they tell us that this segment's the same as that segment? They didn't put no markings on it. Segment CF, BE, and AD intersect at point A. True or false?
Yes, yes. Yes.
True. Angle BAC and angle CAD are complementary. Angle BAC, that's this angle right here.
True.
And angle CAD is this angle. Complementary means what?
Add up to 90.
They gave us that little box right there, so that is true. DAE is a right angle. DAE is this right here.
True. False. No, false.
You can't assume, it's true because in
No,
90,
because
90 equals 180.
You can't assume that this is a right angle, but what can we assume about
Supplementary.
that right there, BAE? It's a straight angle, right? It's 180. And if this part over here is 90, what's the only thing this part over here could be? 90. So that is only in Jacob's world. Yeah, we're done. Looking at this just real quick. And if you wanted to write this down, that's up to you. It's like a Venn diagram. Stuff that you should have learned somewhere in the past. You got real number, you got complex numbers, imaginary numbers, so on, so on, so on. This is all the numbers in our number system. Alright? The ones that you probably messed with in the past are in the green right here. Those are the ones you've messed with in the past.
This will be on our
This is just something that you should already know, but I mean, it might say a whole number. It might ask you something about a whole number or something maybe, and you need to know
Why is positive?
what whole numbers are. Natural numbers. Natural numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on, so on, so on. Alright? Whole numbers, what's whole numbers put in there? 0. Add 0. So just add 0 to the natural numbers. Integers. What's integers put in there? Adds in the negatives. Adds in the negatives. So each time we're adding on a little bit. Rational numbers. What rational numbers add into it?
Fractions.
Fractions and decimals. Fractions and decimals. Does anybody know what irrational numbers are? And maybe we shouldn't put that decimals part on there because that's probably going to confuse somebody. Dawson was right. Fractions.
Negative square root.
Then these are
something that goes on forever.
something that goes on forever. These are the decimals that do not end,
Pi.
like pi. Now, rational numbers still has decimals in it because 3.5 is a rational number. All right? So when I put that down there, it wasn't like I was wrong, but it seems to confuse some people. And all of those put together is the set of all the numbers that you've probably ever dealt with in your life, which is real numbers. And then from there, and not this year, but some point you'll maybe in your mathematical careers, you'll learn about imaginary numbers And then when you put imaginary numbers together with real numbers, that's a set of complex numbers, and that's all the numbers that are in our number system that we use. Hopefully some of you will use complex numbers at some point. Complex numbers, or I'm sorry, imaginary numbers and complex numbers are things that you use to, for like engineering a lot. To figure out stress and figure out how much something can handle. All right, set your books off to the side. I'll leave that up there for another second or so. Take your books off to the side, get out. I'm going to go over the chapter 1 review. Has everybody about got all that? Is that a yes?
No. Look at that second one.
With each one, sometimes I write it this way, sometimes I don't. As far as spread them out, sometimes I'll put it all together and you do whatever you want with it. This time I happen to spread them out. Things you should know for this test on Wednesday. Number 1, be able to name points, lines, angles, rays, segments, so on, so on, so on, planes, everything. Be able to name all those. You've got to make sure that you're using your symbols and the correct number of letters. So be able to do all that stuff. So if I wanted to name a point, point B. If I wanted to name a line, you got to use 2 letters, A, B, and use the line symbol. If I want to name a ray, use the ray symbol and 2 letters.
Wait, can't you name a line with
I'm
one?
going to go back to that here in a second. If I want to name a segment, segment symbol, 2 letters. Dawson's right. Sometimes with a line, can you name a line with 1 letter?
Yes, that's not okay.
It's okay. It's not what I like. But if they give you a letter out here, and it's a lowercase letter that goes on the arrow, then we could just call this line M.
Wait, can you repeat why you don't like that way of doing it?
It's just easier to know one way and not do it that way.
Is this separate from the notes we've been taking, or can this like go?
That's up to you. I mean, if I said that you could use 1 page of notes on the test, if you wanted to use this page of notes and fit in other stuff around it, then, but if you just add it on to like the back of some other set of notes and you use this 1 page and it's got those other notes on it, that's fine also.
Alright.
So that's totally up to you. A plane, remember with the plane, how do you name a plane?
3 non-collinear points.
3 non-collinear points, 3 letters. So maybe ABC or something, or ACB. And we could also name a plane if they happen to give us 1 letter in the corner without a point, then it could be named plane K. Angles, how many letters to name an angle? 3. Q, R, P is one way. What's another way that angle could be named?
PRQ.
PRQ. And then let's say there's only 1 angle in the picture. What's the 3rd way that angle could be named? Angle R. And if they have to give us a number, we could do that. Name it with a number. What's collinear mean? Yeah, collinear. Same line. Just real quick. What's coplanar mean? Same plane. Things on the same line, things on the same plane. Opposite rays form a what?
Line.
Form a line, good. Congruent, what's congruent mean? 2 words. Same
Measure.
Measure. When I say same measure, because it could be same lengths if they're segments, same measures if they're angles or segments. Again, make sure this is a set of notes that's going to be in your binder. Segment and angle addition postulates. Guarantee I put a problem on there. You have to draw this. B is between A and C. So what's going to go right here? A, what goes here?
B.
C, what goes here? B. Then they're going to tell you this is X. This is 2X plus 3. The whole thing is 28. What do you got to do from there?
How?
Set up the equation. This plus this equals the whole thing. What was? Somebody asked a question. Is that you, Pete?
I just said, you gotta do algebra.
Oh, algebra. Same thing with angles. If I drew this, what do you know about these two angles?
They are.
They add up to equal the whole thing, whatever it happens to be. Be able to use a ruler. Make sure you know on your inches side what you're doing, on the millimeters or centimeter side what you're doing. Remember on the metric, on the centimeters, it's always going to be something like 2.3 or 4.5 or something like that. On the inches side, 2 1/8 inches. Make sure you remember those. What's a bisector?
The point that separates
Splits something into what?
two.
Splits into two congruent parts. So it could split an angle into two congruent parts, could split a segment into two congruent parts. Now, Jacob actually gave us the definition of this. What's a midpoint? That's the point that splits it. Splits a segment into two congruent parts. Midpoint and distance formula, you want me to write those down again?
Yeah.
x2 plus x1 divided by 2, comma, y2 plus y1 divided by 2. If they ask you to find a midpoint, what formula are you going to be using? That midpoint formula. That's the midpoint formula. And I'm not writing that down, I'm just going to draw an arrow. That's the midpoint formula. Distance formula. D equals big square root. Parentheses, minus in there, plus, parentheses, squared, minus in there, x2 minus x1, y2 minus y1. Well, give me an example of a question if you knew you were going to use the distance formula. Find the distance
Between this point and this.
between this point and this point. So on both of these, if you're using either one of those, what are you going to see on the test, on the paper? Yes. Am I in your way? Is that what you're hollering at me about? My pen work? There. You're either going to be given two ordered pairs or you're going to be on a graph. So you see a graph or you see points, you're probably using one of those two formulas. Good bet.
Great bet.
Maybe not great. For this test, yeah, it probably would be a great bet. Ready? Next one, be able to name polygons, be able to give them their names. Seven-sided polygons of what? Septagon. How are you going to be able to do that? And Jacob just missed one because he wasn't using his head. Because what could he do? That he's closer than any of the rest of you.
Look up there.
He could look right up there. Now,
Yeah.
I'm not taking that. Now Jason, he's sitting way back here. Maybe his eyesight's like mine and it's not so good and he can't see that far.
Just get up and walk
Oh, the pencil sharpener's up there, so he walks up through here trying to be nice, not walking through the middle of everybody.
Wait, does that mean I get to do that?
Oh, the pencil sharpener's over there, how you gonna do that?
Better put him by nine.
Oh yeah, I can get a tissue.
So Jaden comes over here picking her nose.
Your camera
Are you
lens.
keeping it up?
There you go.
Yeah, he is.
The
Oh,
the posters will be up all year long. So somewhere, there's probably another poster in here somewhere that talks about supplementary and complementary angles. Maybe it's not up yet, it might still be laying in the pile back there. Could do that. Just have to talk to my intervention people, because I don't put them up, I just tell people other people. Find areas and perimeters. Areas and perimeters, let's just do for area. Let's do a triangle. What's the formula for area of a triangle? 1/2 times base times height. The only other shapes we have are squares and rectangles that we're actually going to deal with. What's the formula for area of a rectangle? How about if we just do base times height? Length times width means the same thing. Could you use that same formula for a square? Yeah, because a square is a rectangle. How do you find the perimeter? Add all sides. You don't really have to use a formula. Those are things, again, a lot of this stuff that you've seen in the past somewhere, and I'm hoping you remember it. It's not something that I should have had to teach you. Half base times height, you should have known. Length times width, or base times height for area of a rectangle, you should have known. Now, am I just going to put a rectangle on there like this and say find the area? Probably not. It's probably going to be on a graph, and then you have to graph the points. And if you have to graph those points, how are you going to find the length of that side? Either use the distance formula or count if it's vertical or horizontal. You like the ones that just count? Special pairs of angles, complementary, supplementary, vertical. Make sure you write quickly here. Pretty important that you know all those. Be able to do the coordinate plane. We've been talking about that all the way through. Be able to set up and solve equations. That's the end of the notes right there. But those special pairs of angles, very, very important. You are going to grab, this is your review packet. This is your review packet. It's got like 50 problems on it or so. You don't have to do them all. You're going to do 30. Should I say 30? Hold on, let me look, because no, because there's 25 multiple choice. And if I tell you do 25, everybody does every multiple choice. Let's do 35. Got to do at least 35 of the 50. 35, make sure you grab it. Test on Wednesday. First one, name points, lines, planes, angles, so on, so on, so on. We're going to start off with a point. I get to this and this. How do I name a point? What's the symbol for a point? It doesn't have a symbol. So how do you name a point? The word, point A. All right? How do you name a line? How many letters? 2 letters?
And then a line.
Is that it?
Oh, you got a line.
You got to use the symbol. Make sure you're using the right symbol. How about, let's, because I skipped a couple here. How about if we wanted a ray instead of a line?
You gotta draw this report in one way. Segment, you just draw.
2 letters.
Like that. Like just draw segment.
2 letters on both of them. Make sure you're using the right symbol on everything. You don't put symbols on something that gets marked wrong.
It needs a ray, you said?
That's a. This is a line, ray, segment.
Right, you should have this as your segment.
I know, but I'm just making sure.
That's good. Nothing wrong with that.
Alright, you gotta draw an angle.
At least
here.
I'm writing it down.
An angle. You should be writing it down too.
I'm a professional at
It
that.
still goes right back to his binder. What's gonna happen on his binder? He's gonna get a crappy grade on his binder.
Wait,
He
you
could've
should
got the
have
points.
said, planes too.
Yeah, I'm gonna put that on here. That's right. An angle, different ways to name an angle. Could name it angle 1, could name it angle EFG, I heard. How else could you change that around?
Angle E or GFE.
Angle GFE, and for that angle, if it's only got one angle in the picture, it could also be named angle F.
Yeah.
Planes, how many letters to name a plane?
3.
3. Remember, so it could be like plane, no symbol,
Wait, can I have one also?
plane, QRT. Could be that way. Alright, any 3 letters, any 3 points that fall on the plane. It could also be named with 1 letter if they give you the letter in the corner without a point with it. So this would be plane W. Now that takes us back to a line over here. Is that the only way to name a line?
No.
No, if I had this line,
Be line like O or whatever.
how could I name that?
Lowercase m.
Line.
Not capital.
Lowercase m. But that m's got to be out there on the arrow. It can't go with a point on the line. What's collinear mean? Same line. What's coplanar mean?
Same plane.
Same plane. Let's go back to collinear. Points Z and R, are they collinear?
What?
Point Z and point R, are they collinear? See, and I guarantee I put that problem on the test, and I told you this when we talked about it. Point Z and point R, are they collinear?
Yes.
What do we know about any 2 points? They're collinear. No matter where those 2 points are located, is there some line in our world that connects them? Now Wyatt, when we do point Z, R, and P, are they collinear?
No.
Then we don't know. We need the picture to tell. Opposite rays. Opposite rays make a what?
Straight angle.
Straight angle. Make a line. Straight angle, whichever. Make a line or straight angle. Congruent. What's congruent mean? 2 words.
The same.
Same measure. Same measure.
It's a little squiggly line with an equal sign below it.
It looks like this. Same measure, whether it's angles or segments, same measure is what congruent means. Segment and angle addition postulates. Guarantee I put a problem on there that says B is between A and C, and you're going to have to draw it. So we go to draw this. What letter is going to go right there?
B.
B. What goes here? A.
C.
C. And then I say something like AB is 2x, segment BC is 3x minus 2, and segment AC is 14. You got to be able to label it and do all that.
Gotta do 2x plus 3x minus 2 equals 14.
The equation would be 2x plus 3x minus 2 equals 14. This
5x.
plus that, we don't want to solve it. That plus that has to equal the whole thing. And it works the same with angles. If I told you this angle was 20 degrees, this angle was 32 degrees, how much is that whole angle? 52 degrees. Be able to use a ruler, centimeter side of a ruler. Give me a possible measurement on the centimeter side of a ruler. 3.7 centimeters. It's always going to be in decimal form, right? Never ever 3.5, 3 3/4, never. On the inches side, give me a possible measurement.
3 and 3/8.
3 3/8 inches. All right? So be able to read those, the different things on there.
I guess 3/8 is also 3/16.
Yeah.
Or 6/16.
It'd be 6/16, but we don't want that because 3/8 is the reduced one. That's the proper one. Get it on.
4/8.
So be able to use a ruler. No bisectors. What's a bisector do?
Where the 2 lines intersect?
right? Or what, like?
Not
A
two
bisector
bisectors.
splits or splits a line in two congruent parts,
Not a line,
angles.
maybe an angle or a segment, right?
Yeah, you can't split
You
one.
can't split a line into two equal parts. You can't split a ray into two equal parts either.
Ah, I was.
So bisector splits into two congruent parts.
Midpoint also.
It could be a segment or an angle. Those are the only two things that you can split into two equal parts.
Does a midpoint also?
A midpoint is a bisector, but it's a bisector for only a what? For a segment. For a segment. Splits into two congruent parts. Sorry, I forget every now and then, read not to write in cursive.
I cannot read cursive, I can't read my own word.
I could read cursive.
I can read cursive.
A lot of times I remember.
No, I cannot read perfect.
Two formulas, you want me to write them down or do you know them by heart?
Right there.
Right there.
Write them down?
Right there.
I know, but they won't be there come Wednesday.
Can we write these on like our page?
That's what I'm saying,
I'm
yeah.
gonna write her down. You don't need to write it.
I'm not sure why you're still not writing this down. I still haven't beat it into your head that this is part of your binder and it has to be in there regardless. Alright.
Well, you ain't gonna write it down.
Hey James,
Just
you need
write
to help
there.
him out. We write these down. X2 plus X1 divided by 2. Y2 plus Y1 divided by 2. That's the midpoint formula. Remember, midpoint's always going to give you an ordered pair. It's going to give you an X coordinate and a Y coordinate. If you come up with just one number for your answer for midpoint, you screwed up.
What? What happened to X, M, and Y?
I just didn't put it out front here. It's like this, Wyatt. You remember when we do formulas for like area, and we do area equals length times width, and you guys always just remember length times width, and you don't put the A out in front? That's the same thing.
Oh, okay.
The X is the X is your answer, and the Y is your answer.
Alright.
Distance formula. Got the big radical, the big square root. Every single time it's this. Guarantee there's a whole bunch of these on there. We did them all throughout the chapter. You've got to know how to do distance formula, midpoint formula. X2 minus X1, Y2 minus Y1. Again, does it matter which order the X's go in? No, doesn't matter which order the Y's go in.
I thought you just wanted to put it in like bigger. and smaller.
That's usually what I do to make it easier on myself. It doesn't make any difference which order they go in.
Oh, why is there a 1/2 minus 1? Why is it?
That's a Y. Thought we agreed you weren't going to do stuff like that today. On this, watch closely. How are you going to know when they want you to find the midpoint of something? They're going to say find midpoint. So you know to use what formula? Midpoint formula.
We're allowed to use this sheet?
Yeah. One sheet, yeah. How are you going to know when they want you to find the length? Find length or find the distance between these points. I'm going to give you two little hints here. If you see a graph, there's a pretty good chance you're using one of those two formulas. If they give you ordered pairs, there's a real good chance that you're using one of those two formulas. All right? Does that make sense? So if I grab this review packet and I show this to Wyatt right here, Wyatt looks at problem number 9 right there and he sees a graph. What should he think of right away? Midpoint formula or distance formula? He's probably using one of those two. Real good chance. Be able to name polygons.
Can I get them a sheet of that? Did you hand out a sheet that had all of them on?
We wrote them down. Be able to name polygons, all the different polygons. Be able to find areas and perimeters. I'm going to write down 2 real quick. Triangle. What's the formula for area of a triangle?
Base times height. Half times the base times height.
Area equals 1/2 times base times height. Some of you were getting ready to say base times height divided by 2. That's the same formula. It's the same thing. So either one of those. What's the formula for a rectangle? Area equals what?
Base times height.
Base times height or length times width means the same thing. How do you find the perimeter of any shape? Add all sides. If you're on a graph, we're on a graph, and you got this rectangle, and it says find the perimeter, you're going to have to find the length of each one first, and that probably means using what? Distance formula. Or, if this is vertical, you could do what? Just count the blocks.
Didn't you say always find all the sides first before you even do it?
Last thing, special pairs of angles. What's complementary mean? 90 degrees. What's supplementary mean? 180. What do you know about vertical angles? They're congruent. Coordinate plane, we just got done talking about that. Anytime you see a coordinate plane, what are you going to think of? Distance or midpoint formula. Be able to set up and solve equations. We just got done doing a whole bunch of that. Be able to set up those equations. This plus this equals 180. This plus this equals the whole segment. Whatever it happens to be.
I'm definitely gonna go home, write some more notes now.
Again, when you come in on Wednesday, 1 page of notes. You're allowed to use 1 page of notes
Front and back?
on the test. You're going to grab this. This is your assignment. There's 50-some problems on it.
Oh my god.
53.
Now, since Wyatt said that, I was going to cut it down.
I know.
But
It's perfect.
since he was complaining already and hadn't even let me finish, he just made it harder on all the rest of you. So you can thank Wyatt as soon as you walk out of
Got
my
a better
room.
on my fellows. Got a better on my fellows.
What I'm going to do, you can do any 35. Normally, I will say you can do any 35, and any you do past that will be bonus. This time I'm not going to say that, but I would highly suggest that you do all of them because they're not that difficult. So grab one of those as you walk out. Do next time, test on Wednesday.